Now let's take the next example, 47 into 41. Now what happens here? Now 47, you would recall, we can write as 5 into something plus 2, and 41 we can write as 5 into something else plus 1. So when I multiply these two, I get 5m into 5n, then 5m into 1, then 2 into 5n, and 2 times 1. So this is what I get. Now you notice that all of these three terms have 5 as one of the factors. So 5 times, so I'm left with 5 times 5mn. I'm left with m here, and I'm left with 2n here, and 2 times 1. So this is immaterial. What I clearly recall is m and n were natural numbers that I had assumed. So 5 times the simple computation of natural numbers, their additions and their products, it gives me another natural number. So this whole thing is a multiple of 5. And what I'm left with is 2 into 1, which I have deliberately not multiplied so far, just to tell you that 2 is the remainder that I got from 47, dividing 47 by 5, and 1 is the remainder that I got from dividing 41 by 5. So the answer 2 comes from remainder 1 multiplied by remainder 2. Right? So this is a very important concept. So just to clarify, so if two numbers a and b are added, the sum will give me the remainder. So when a divided by a number gives me a remainder, let's say ra, and when b divided by a number, let's say gives me a remainder rb, then their sum will give me the remainder ra plus rb. Similarly, their difference is going to give me the remainder ra minus rb, and their product is going to give me a remainder ra times rb, right? But things can get a little bit more complicated when, let's say, this happens. Let's take this number 47, or let's say 48, and let's say 54. Let's say what happens when 48 and 54 are added. Now I'm continuing with my divisibility by 5, right? So when I divide 48 by 5, the remainder is 3, and when I divide 54 by 5, the remainder is 4. Now when I add these two, by the theory that I've just learned from here, the remainder when the sum is divided by 5 should be 3 plus 4. This should be the remainder when this sum is divided by 5. However, I get a 7, which is more than the divisor. But can the remainder ever be more than the divisor? The answer is definitely cannot. Now if the remainder cannot be more than the divisor, then all I would do here is I would subtract as many divisors as possible from this number. So I notice that 7 has 1 5 and it still leaves a remainder 2. So I would just eliminate this, and the final remainder from this sum is going to be 2, right? So the whole idea is that whenever you get a remainder which is greater than the divisor, you remove as many complete divisors from it as possible. Or in other words, what you could do is you could divide this remainder by the divisor, and what you're left with is the final remainder. So it's the remainder from the remainders that you get, right? Similarly, if let's say I were multiplying, so this is one of the problems, right? This same thing could occur when I'm multiplying two numbers. So let's say when I'm multiplying 48 and 54, this gives the remainder 3, this gives the remainder 4. The product, whatever the product is, so I'm not calculating the product or the sum here. The product should give me a remainder 3 into 4, which is 12. Again, 12 cannot be a remainder when I'm dividing by 5. So I'll divide 12 by 5. It gives me a 10, and this is what my final remainder will look like, right? So I've eliminated 2 5s from this remainder, because then they would add up to the main sum, which is divisible by 5. I'm left with a 2, right? So this is the remainder. However, when I'm subtracting, so we figured what problems we could face here, and we figured how to resolve them. But let's look at what happens in subtraction sometimes. Now let me take another couple of examples. Now let me take a number 548, right, and let me subtract, let's say 99 from it, right, and we have to find out what the remainder will be when I subtract these two numbers, right, when I find the difference of these two numbers. Now 48 gives me a remainder 3, right, because 545 is a multiple of 5 and 3 is what I get as a remainder, but 99 gives me a remainder 4. So by what I've studied so far, this difference should give me a remainder 3 minus 4, but 3 minus 4 is minus 1. Can I have a negative remainder? I cannot. So how do I resolve this situation? It is not very different from how I'm resolving my previous situations. Now previous situations, whenever a number was crossing 5 or the divisor, I was removing multiples, as many multiples of divisors from it as possible. But here, if my number is smaller than it is in the negative territory, all I got to do, my final answer will be, I'll just add one round of divisor to it. So the answer is 4, right? So what we've studied here is we've resolved if the remainders are greater than the divisor, then what do? We remove as many divisors from it as possible, and if the remainder is less than 0, which is not permitted, I would add one divisor to it to get the final remainder.